Gad. عبد الله إبراهيم تبع بأخوة معكم عبد الله إبراهيم فرح نور يونس مكايل مقدرسيات سمران. Yep, that's me. Okay, now let me teach you about hyperbolas. So, a hyperbola. Here is a standard equation right here. X minus h squared over a squared minus y minus k squared over b squared equals 1. Or it can be y minus k squared over a squared minus x minus h squared over b squared equals 1. The reason why there can be two standard equations, because if a is greater than b, then it transverses the vertical, but if b is greater than a, then it transverses the horizontal. Right here, here's a basic example of a hyperbola. H and k represents the center. These are both vertex, and it depends on a. Foci is within the hyperbola, like you know how ellipses goes inward. It's basically like an ellipses, but its hyperbolas are going outwards. And then here, these are 2 points, but these are represented by b in the equation. So, when it comes to figuring out what a or b is, you can use this equation called b squared equals c squared minus a squared. And what we've learned is baka, baka, and it's like a bird. You know why it's like a bird? Because when we go back to the graph, this kind of looks like a wing. So like baka, that's a hyperbola. Now, let me go off to a parabola. A parabola's standard equation is x minus h squared equals 4p times y minus k, when p does not equal 0. P, right here, is the distance between a directrix and vertex, or vertex and foci. So here, right, is a standard equation, or like example of a parabola. See how the vertex is right here? The directrix is probably going to be underneath the vertex. When it's flipped on the other way, the directrix will probably be above the vertex. The foci is within the parabola, so if it was the inverse, it would be, the foci would be down here when the vertex is right there. Standard equation overall, when we talk about parabolas, is a x squared plus bx plus c equals y. So that's a parabola for you.
Hi, I'm Suzette. Unlike Nigad, I don't have a middle name because I couldn't afford it. So instead, I'll talk about ellipses. The standard equation of an ellipse is x minus h squared over a squared plus y minus k squared over b squared. Now, you might be wondering as to what h, k, a, and b, what those variables stand for. Well, 2a is the distance of the major axis, and the major axis is the longest distance in the ellipse. So in this case, a major axis would be the x-axis, and if you wanted to get a, you would just divide this distance by 2. The same thing goes with b, only b is a minor axis, meaning it's the shorter length, and again, if you want to get b, you just divide the distance by 2. And then h, comma k represent the center point of an ellipse, so h, comma k, center of an ellipse. And then c represents the distance from the center to the foci. Now the foci right here are these 2 points within the ellipse, but they're not quite touching the outside. They're just they're at a certain distance from the center, so the distance from the center to this foci is the same as the center to this foci. And a good equation to remember is c squared equals a squared minus b squared, which is also spells out cab, and a fun way to remember it is that cabs drive around an ellipse. So that's how you can remember ellipse. And now I'd like to move on to the standard equation of a circle. Now, the equation for a circle can be written out in 3 different forms. In x squared plus y squared equals to r squared, where r represents the length of the radius. Or another way you can write it is x minus h squared plus y minus k squared equals to r squared, where r again is the distance of the radius, and h comma k represent the center of a circle. Or you can also write it x minus h squared plus y minus k squared all over our radius squared over radius squared, which equals to 1. So these are just some different ways in which the equations of a circle can be written out. And this is a picture of a circle with h comma k being the center of the circle. Now, how does this relate to a real world application? Well, right here, as we all know, the sun is the center of our solar system. So in reality, the sun could depict kind of the h comma k point you would have in an ellipse. And then, as we all know, planets travel around the sun in an elliptical form, sort of like this. But we also know that planets orbit the planets. Moons orbit the planets also in an elliptical shape. So right here, a moon could be sort of like the foci of the greater ellipse. So we'll start off with example 1, and example 1 is sort of a easy to medium problem level. So yeah, we'll go ahead and start. So the two kinds of information that they give you are the foci, which are located at point 0, 1 and 4, 1. And then they also tell you that the length of the major axis is 6. So in these types of situations where they ask you, and by the way, we're looking for the standard equation of an ellipse. And in these situations, it's always good to have the standard equation written here somewhere. So we wrote it up here. And then the next thing you do is that you plug in your foci kind of just like on a coordinate plane, like so. And so now you have foci at 0, 1 and 4, 1, and you're looking for the center. Now you think about it, and then you deduce that the center is at 2, 1, since it's in the center of both foci. Now they tell us that the major axis length is 6, which is, and then here the major axis represented by A. So you know that 2A equals to 6. And now using algebra, you solve for A, and you know that A is 3. And now another thing that we want to know is B, the length of the minor axis. And for this, we use our handy-dandy equation, B equals to the square root of A squared minus C squared. And so then we plug in B equals the square root of 3 squared minus 2 squared. Now you might be wondering where we got the 2 squared from. Well, the 2 squared, which is C, basically represents the distance from the center to one of the foci. So from right here, there is a distance of 2, just like here there is a distance of 2, which is why we plug that in. And we get B equals to the square root of 5. And so now we basically have everything we need to know to do our standard equation. We have A, we have B, and we also have h comma k, which is the center. And so now we just plug it into our equation, like so. X minus 2 squared over 3 squared plus y minus 1 squared over square root of 5 squared. And now this right here isn't fully simplified because you have a radical in the denominator, and we don't like that. So we basically, and also you have to square it, so we just simply square the denominators, and we have x squared minus x minus 2 squared over 9 plus y minus 1 squared over 5, and this is the standard equation of your ellipse, and you're done.
Now we're going to start with example 2. Example 2 is in hyperbola. Like before, I said that a standard equation of a hyperbola would be this. This is the one we're going to be using. We are given 2 points for the foci, -1 and 2, and 5 and 2. vertices, we also got 2 points, which is 0 and 2 and 4 and 2. Here's the diagram, and this is how you express both the foci and the vertices. So the center right here would be 2 and 2, because now you know that the vertices and is between both vertices right now. Since you are looking for B, you're going to be using, like I said before, Baca. Plug in, you know what 3 is, because that's going to be the distance between the vertex and the foci. And then we already have received information because of A is right here. So you simplify, you find out that B equals square root of 5. Since now you have B and both A, you can plug that into the equation. And since you have both H and K, because you know what the center is, you can also plug that into the equation. After you simplify that, overall the equation will be this. And our goal of this whole thing was to figure out the equation of this hyperbola given this information. So that's example 2.
I'll conclude our tutorial on conics. Thank you very much.
Have a nice day. You know I'm not going to need Khan Academy.
Nope, you are.
Yeah.
You don't need Khan Academy. Thank you. Danny, I hope. Are 2A represent the distance of the major axis, and the major axis is the longest axis. So in this case, get out.
No, wait, we're gonna keep that part because I love.
Oh my god, no, we're not. No,
no, I love that. No, hi, Christian. No, I'm keeping this.
Christian, you don't know. I'm fine.